Myself, Govind Neglur. I welcome you all for the video lecture series on the course named Problem Solving and Programming in C. In this session, we will learn one of the most important feature of C named pointers. Because of these pointers, C is considered as a powerful programming language. It lets the programmers manipulate the data efficiently and easily. So without waiting further, let's get started. What is a pointer? Technically, a pointer is a derived data type in C. As we have seen earlier in the previous videos, in C, a data type can be classified into three categories: primitive data type, derived data type, and user-defined data type. Examples of primitive data types include int, float, double, char, and wide. Examples for derived data types are arrays, functions, structures, and pointers. Note that in the previous video sessions we have dealt with arrays in detail. You can have a look into those sessions. In this session we will be talking about pointers, which is a derived data type. Coming to user-defined data type, we have typedef and enumerated data type, which are the examples of user-defined data type. Now coming back to pointers, as stated earlier, a pointer is a derived data type, meaning it is derived from the primitive data types. So the formal definition of pointers goes like this. Formally, a pointer is a variable that stores the address of another variable that belongs to the same data type as that of pointer variable. Let us try to understand this seemingly complicated definition in detail. But before that, we will list some of the benefits of using pointers. First benefit we can have is pointers are efficient in handling arrays and data tables. We will see in this session how by using pointers the handling of arrays becomes very trivial. Similarly, we can also use pointers for two-dimensional or multi-dimensional arrays. We refer this as data tables. Next benefit is pointers can be used to return multiple values from a function. We will be learning the concept of functions in C in the future video sessions. However, a point to be noted at this point before learning function is that in C you cannot return multiple values from a function. This is true in case of multiple programming languages like Python, wherein you can return multiple values from a function. This is in sharp contrast in C, wherein you cannot return multiple values from a function. But then how can I make a function return multiple values? Technically not possible, but via use of pointers, indirectly I can make a function return multiple values from a function. How? We will be seeing in the further sessions. Use of pointer arrays to character strings results in saving data storage space in the memory. As we have seen in the last session about array of strings, if we had used array pointer arrays to character strings, we would have ended up in saving a lot of data storage space in the memory. Hence, pointers are memory efficient. Pointers allow C to support dynamic memory management. This is also one of the most important aspect of a programming, which is allocating the memory during runtime. Hence the name dynamic memory management. In the sessions on arrays, we had seen that when we are reading the arrays, we first read the size of the array as n, and also we had ensured that n should not be greater than the size of the array that was allocated during the declaration. So if I had written int a of 10, that value of n should not exceed 10. If it exceeds 10, I had told it in the video session on arrays that the program will not work for more than 10. Now, because I had specified int a of 10 statically or during program typing, this is what we refer to it as static memory management. Is there a way to dynamically allocate memory? Not only for arrays, for any other variables? Yes, there are functions like malloc, calloc, and realloc, which can be used to specify the memory or allocate the memory dynamically. This is referred in C as dynamic memory management, and without the use of pointers, dynamic memory management is just not possible in C. Pointers reduce length and complexity of programs. Pointers increase execution speed and hence reduce execution time. Note that execution speed and execution time are inversely proportional. So pointers increase the execution speed and hence reduce execution time. So any feature that we see, it should increase the execution speed. Automatically the execution time will reduce. So usage of pointer have these benefits. These are not the only benefits. There are in fact large number of benefits by using pointers. I have just listed very few and the most important ones in this list. Having listed various benefits of pointers, let's try to visualize what a pointer is. We all know when we create a variable, it gets stored in a physical memory, usually a RAM part, which we call it as memory address. Memory addresses are usually expressed in hexadecimal numbering system. You might be asking the reason why only memory addresses are allocated as hexadecimal numbers, because actual memory addresses are in binary numbers, but since humans cannot remember or interpret binary numbers, and binary numbers can easily be converted to hexadecimal notation using what is called as BCD, called as binary coded decimal, and hexadecimal numbers are easily interpreted by humans. Because we can easily convert binary numbers to hexadecimal using BCD notation, all the memory addresses that we see are all hexadecimal numbers. Every time a program is run, depending on the availability of RAM, different memory can be allocated to the variable. Let us consider the statement. Here I have written int a equal to 10 semicolon. So what happens when I do this, or when I run this code? Assume that I am writing main and compiling this program without any errors, and when I run this, what happens? In the memory, usually in the RAM part, some static memory will be allocated, and the value 10 is assigned to that memory. This is depicted here. The memory representation of the same variable is actually shown in this diagram. For ease of use, we will represent memory addresses as decimal numbers, because we have noted that actual memory addresses are hexadecimal, but for ease of sake, we are representing this number 2000 as decimal number. So what this diagram says, in the diagram, a rectangular box represents a memory location or address, and the number inside the box, which is 10 here, signifies the value assigned to the variable, and the value at the bottom is the actual memory address. The character that is specified here is referred to as a variable name. So name of the variable is shown at the top. I will call this type of representation as memory diagram, and this helps programmers tremendously to analyze several bugs in the program. So we will be using memory diagrams extensively to understand various features of C. In this session, we will use memory diagrams to better visualize and understand the concept of pointers. Now, what if we would like to print the memory address associated with the variable as the output? What do I mean by that? When I say printf %d, a, it would print 10. So what does that mean? It is printing the value associated with this variable. Now what if I want to print 2000? I can write a statement like this: printf %u ampersand a. As you can see here, we use the symbol called ampersand to display the address of a variable. This is the reason why ampersand is to be used while reading a value using scanf. In fact, when using strings, we had noted that we should not use ampersand. The real reason is we want to store the read value into the variable, and without knowing what address the value is to be stored, we cannot store the value successfully in the variable. To address this problem, ampersand is preceded before the variable name in scanf. So you can see here, before specifying a, we use scanf ampersand. By using ampersand, the compiler knows exactly to which address the value entered by the user is to be stored. Hence, ampersand symbol or operator is famously referred to as address of operator, meaning it gives you the address of a variable. Note that in C there are two operators with the same symbol ampersand. One is a unary operator, which we just discussed, and the other is a binary operator, which is used as bitwise AND. In this session we will only discuss ampersand operator as address of operator. You might also notice while printing I have used percentage %u. Why? Because memory addresses tend to be long numbers and are always positive numbers. Hence, percentage %u referred to as unsigned int, which will print all the numbers provided in address A, in which A is stored, all in positive values, because it will be unrealistic if we print the memory address as negative values, which will be the case if you would use percentage %d. So important point to be noted here is whenever you are printing the memory address, we should always use percentage %u. Hence, what this statement prints? This statement prints the address of A. So instead of printing 10, it prints 2000. Now, having seen how to print the address of a variable, the next question is, can I store the address of one variable as a value in another variable? What do I mean by this? The situation is similar to this. I can create one more variable called B, but that B, instead of storing any other value, I want to store the address of A. The address of A is 2000. So you can see here the memory address of B is 3000, but I should store the address of A, which is 2000, as a value in B. So this is like, suppose I want to print the address of a variable. How can I store the address of one variable as a value in another variable? To achieve this, we can write this statement: B equal to ampersand A. Just now we had seen using printf to print the address of a variable, we use ampersand. Now with this statement, what I am doing is I am storing the address of A as a value in B. So that's why I am writing int B equal to ampersand A. With this notation or with this assignment, we can easily store the address of one variable in the another variable. However, we are not yet done. What if we want to know the value associated with the address that we just stored? Confused? What do you mean by this? It means, what if I want to print the value 10 just by using B? Is this possible? The answer is yes. This is where the concept of pointers comes into picture. Without making a variable as a pointer, we cannot achieve this. What do we can't achieve? Printing the value associated with the address. Here we are interested in printing the value which is associated with the address 2000. So can I print the value 10 by using B? So this cannot be achieved using a pointer. So how do we make a variable as a pointer? It can be done like this. Need to create one more variable. This time I'm going to create it as C, and I'm using a notation called star. So star C equal to null. So this star makes a variable whose data type is of type int, a pointer variable. So when we do this, as a pointer variable is a normal variable, it also gets created in the RAM part, and this time let's assume that a separate memory of 4000 gets allocated for this variable. So to be able to print the value of 10, we have to use pointer, and we will be using C, which is a pointer, to get this done. To do this, we will write this statement C equal to ampersand A. Note that this statement C equal to ampersand A and B equal to ampersand A seems one and the same, but the difference is here the B is a normal variable, but C is a pointer variable. So what happens when we do this? You might have guessed it. The 2000 gets copied into C. Now we use this notation wherein we say that this C points to the variable A. So when we print the value with star C, what happens? Instead of printing 2000, it prints the value associated with this address. So what is the value associated with this address 2000? The value that is associated with this address 2000 is 10. Hence, this statement prints 10. This is signified with this animation. So as you can notice, we can easily understand the concept of pointers if we are able to understand or represent the various variables via memory diagram. We now have a mechanism wherein we can make a variable to point to the address of another variable and print its associated value. Now you can understand the formal definition of pointers, which was, it's a variable which points to the address of another variable and can fetch the value associated with that address. Here C is a pointer variable which is said to point to the variable A. Hence variable C is a pointer variable. So syntactically speaking, to make a variable as a pointer, we use an operator called star. Hence, also note that we use star operator to fetch the value associated with this address. So when we are declaring a variable as a pointer, we use star and the name of the variable. So we precede the variable name with star, and when we want to access the value associated at this address, we again use the notation called star. Hence, star operator is famously referred to as value at operator. So we will note few points here. Ampersand operator is famously called as address of operator because, as we saw previously, it can be used to refer the address of a variable. Star is famously called as value at operator. It is to be noted that both ampersand and star are unary operators because their corresponding binary operators are also available and their meaning is totally different. Also, the unary operator ampersand, which is address of, cannot appear in the LHS of an expression. What do you mean by this? It means the C statement or assignment statement like ampersand b equal to 2000 is invalid. Why? You can just try to think the reason and let me know in the comment section. Also, star can appear both in LHS and RHS of an expression. Again, why this is true? Please let me know in the comment section. Now let us try to analyze the following code, and by analyzing this code we will have a more insights on the understanding of pointers. Let's get started. I create two variables here, I and j. So if I try to represent a memory diagram for this, we might represent it like this. So let's assume that the variable I gets allocated memory in the RAM part as 1000 and j gets allocated as 2000. Next, I create a variable which is a pointer variable. I initialize the default value as null. So please note that pointers are initialized as default values as null. You can also initialize 0 for it. So this is represented like this. So let's assume that the variable p, which is a pointer variable, is been allocated with the memory 3000. Next, I assign a value of 3 to I. So this is straightforward. So when this statement gets executed, the value of 3 gets copied to I. Next, I write j equal to 4. So again, it's a straightforward statement. The value 4 gets copied to j. Next, I write p equal to ampersand I. What's the meaning of this? Ampersand operator is used to point to the address of this variable. So what is the value? What is the address of I? It is 1000. So when this statement executes, the address of 1000 gets copied as a value to p. So this is shown in this animation. We refer to this as p now points to the value at I, which is 3. So what I have done here is I have written j equal to star p. What does this mean? What is the meaning of star p? Star p means the value that is available at this address 1000. So what is the value that is available at this address 1000, which is 3? So this is as good as writing j equal to 3. So what happens to the value of j? Previous value of j is 4. So when this statement gets executed, it gets modified to 3. So this we note it as a arrow mark. So we are able to modify the value of j without using I. So this is indirect way of modification, and this is what makes pointers very powerful in C. Next, what I am doing, I am making p to point to the value of j. So what is the meaning of this? Now the address or the value that gets stored in p is the address of j. So now 1000 becomes overwritten with 2000 when this statement gets executed, and this arrow mark vanishes. So you can see over here. So a value of 2000 got copied to p. So from this point onwards, now p starts pointing to the value which is j. Next, what I am writing, I am making I equal to 5. So the previous value of 3 gets modified to 5. Next, what I am writing, star p equal to I plus 3. What does this mean? What is the value of I? Currently it is 5, and to that you add 3, it becomes 8. So you just guess where does this value of 8 gets copied to P? What is the meaning of star P? The value at the address 2000. So what is the value that is available at the address 2000, which is 3. So you are indirectly copying the value of 8, 5 plus 3, 8 to 3. So you are not writing j equal to 8, rather using the pointers indirectly, you are able to copy the value of 8. So when this statement gets executed, the value 8 gets copied to j. So this is very interesting code which makes us understand the concept of pointers in a more intuitive and innovative ways. Next, we will study a concept of chain of pointers. What is chain of pointers? In C, it is possible to make one pointer point to another pointer. What's the meaning of this? We'll see it in the further points. This is what we call it as creating chain of pointers. So what is chain of pointers? One pointer variable pointing to another pointer variable. So this chain can go on up to many times till it reaches the actual value. What do you mean by this? This is shown over here. Note that in this memory diagram, P2 and P1 are pointers themselves and variable has the value in this block. So P1 points to the value or address 1 of variable value, and P2 is again a pointer variable which points to the address of P1. So here P2 is referred to as chain of pointers because P2 is pointing to another pointer and P1 points to the actual value which is stored in the variable. So like this I can create n number of chain of pointers. So I can create double pointers, triple pointers, so on and so forth. This is shown here. Pointer P2 contains the address of another variable which is a pointer itself. Declaration of such variable is shown below. So I have here just shown how this is represented. So syntactically, how can I create such a chain of pointer variable? It is very easy. You just precede the P2 with 2 stars. So 2 stars means it points to one more pointer and that pointer points to the actual value. So what if I want to visualize like this? I want to create one more variable pointer and I want to make this P3 point to P2. So how can I do it? I need to write it as int 3 stars followed by P3. This is how you do it. Let us visualize it with one sample code. I have a variable x equal to 10. I have pointer P1. I have a double pointer or chain of pointer P2. So if we try to represent a memory diagram for this, it looks like this. Here in the value for x, the value 100 is stored. P1 and P2 are separate pointer variables. They have their own separate addresses. 1000, 2000, 3000 are the addresses, as let's assume that they are created. When I write this statement P1 equal to ampersand x, what happens? The address of 1000 gets copied to P1. This is demonstrated here, and we represent this with an arrow mark, means that P1 now points to x. Then I write P2 equal to ampersand P1. What does this mean? As told earlier, P2 is a pointer which points to the address of another pointer. Hence, two star symbols are used. So what does this mean? Now the value of 2000, which is the address of P1, should get copied as a value in P2. So this is shown with this diagram wherein we say that P2 now points to P1. So having seen this, can I make P2 print the value x? How is it possible? It is very simple. Use 2 stars and write the variable which acts as a chain of pointer. So this statement or this printf outputs 100. This is shown as a blink in the screen. I hope you understood the concept of chain of pointers. Chain of pointers can be easily used to easily replace multi-dimensional arrays. So you can replace index notation with pointer notation very easily, and also this notation saves a lot of space as well as lot of programming effort. Now let's have a quick look into some of the very important concepts of pointers. When we talk about pointers, we can actually bifurcate pointers into 3 types. One is a pointer constant, the other one is pointer value, and the other one is pointer variables. So in all the previous code snippets that we studied, we have indirectly seen all three. Now let us try to categorize what is each of these three mean. What's a pointer constant? All the memory addresses within a computer are pointer constants. So what are the memory addresses? The ones that we represented as 1000, 2000 or 3000 in that memory diagram all form pointer constants. And there are some few things which are required to be remembered with respect to pointer constants. We cannot change them, we can only use them to store the data. What is the meaning of this? Since hardware cannot be changed, so you cannot modify the pointer constants, you can only use them to store the data. Next one is pointer values. What's a pointer value? The value that is obtained by using ampersand operator is a pointer value. So what's the difference between pointer constant and pointer value? Pointer constants are actual memory addresses which you cannot change, but pointer values are obtained by using ampersand operator. So the C expressions that we wrote in the previous slides, like B equal to ampersand A, C equal to ampersand A. So whatever the value that we stored there in C or B, that we refer to it as pointer values. So it is to be noted that pointer values may change from one run of the program into another. Next we have pointer variables. A variable that contains a pointer value is pointer variable. So syntactically in C, we refer or we create a pointer variable as preceding its declaration with a star. Next we will see how arrays and pointers are related. Arrays and pointers can be used interchangeably. What is the meaning of this? Let's try to understand the meaning of this with an example. Here I have defined an array using compile time initialization and specified 5 elements into that array, which is of type integer. This is specified in the memory diagram like this. Let's assume that the initial address or base address of A starts from 100, and we are assuming that this compiler is a 32-bit. Hence, given 100, the next memory address is 104, followed by 108, followed by 112, and followed by 116. So the concept of base address or what is base address of A is been already dealt in the previous videos on arrays. You can please have a look into them. Having initialized the value to A, now I have created or I will create a pointer variable called P. This gets allocated in the rampart like this. So let us assume that P gets a value of 1000 in this case. Next, what if I write this statement? What's the meaning of this? Here note that I have not used ampersand A because when we try to display A using printf, we know that instead of printing 1, it prints the address 100. Hence, ampersand is not used. This is the actual exact reason why we don't use ampersand in scanf while reading a string, because we just want to know the base address of the string, which is the element at the 0th index. And once we know the base address, because it's a one-dimensional character array, all the remaining characters or elements can easily be copied into the string. Hence, ampersand is not used. So what this makes, what is A refers to? A refers to the base address of this array, which is 100. So actually 100 gets copied to P. Let us see this animation. So this is shown like this. Now P is set to point to A. Interestingly, from this point onwards, you need not use A at all in your program. You can just manage all the elements of the array, or you can manipulate all the array. You can do every possible operation on this array using P itself. So this is one more advantage, and this becomes very useful when you are dealing with functions and passing parameters as values to the functions. More on functions in the further videos. So what if I write a printf statement like this? As stated earlier, A prints 100. So what is 100? It's a memory address, and as stated before, to print memory addresses, they are always positive integers. So we use a format specifier called %u. So now we know that this statement A prints 100. What about this ampersand A of 0? It is similar to saying A. So please note one interesting fact here, that always ampersand and square brackets, they gets cancelled out. So when you cancel it out, what remains is A. So technically, what this printf should print, it should print both output as 100. So it prints the output as 100 as well as 100. Next, what if this printf prints? Now let's see, this is again same. I am using *p. So what is the value associated with this address 100? Yes, it is 1. So it will print 1. And we have seen already an index notation wherein a of 0 always prints 1. So now you can see I can use p itself entirely without using the notation a to refer to all the elements of this array. So from this point onwards, I again reiterate, from this point onwards, your program or programmer need not make use of a at all. Directly he can modify the array elements using p itself. This is one of the most powerful feature provided by pointers, and this is why I say that arrays and pointers are used interchangeably, or I can also say arrays and pointers are related. Now, having understood how arrays and pointers are related, let us try to reinforce ourselves with the concept of arrays and pointers with few code analysis. I have this array again. So the memory representation of the array of the same array is shown in the right hand side of this image. I create a variable, a pointer variable p. So this gets created in the memory. Now I don't worry about what is its memory that gets allocated. I just only worry about to which element this p now points to. So keep it in mind, I am not representing the memory of this p, that is currently not required for me. So I omit it in the representation of the memory diagram. What if now I write p equal to a plus 1? What is the meaning of this? What is a? It is 100, and when I say plus 1, it will not actually do 100 plus 1, because you know that when you increment a memory address in array, since memory addresses are contiguous memory locations and each difference between each memory address depends on the data type. Here I am considering a 32-bit integer, so after 100 you don't have 101, rather you have 104. So what does this mean is, when I write p equal to a plus 1, what is 100 plus 4? It is 104. So now this p currently points to the element 2. This is depicted over here. I hope you understood this notation. P equal to a plus 1 means p now points to the second element of this array. This is confusing at the first time, but this is most intuitive and most interesting way to represent arrays and pointers. Next, I am making p equal to p plus 2. This in fact is referred to as pointer arithmetic. What I am doing is I am adding a value 2 to the memory address being pointed by p initially. So currently memory address of p is 104. Remember, even though you are trying to increment it by 2, it will not increment that memory address by 104 plus 2, which is 106, which is wrong. Rather, it increments by always amount 4. So 104 plus 2 is 108 plus 112. So it is as good as 2 into the number of bytes that int occupies. So this statement is very similar to, so 104 plus 8 is 112. So what happens when p equal to p plus 2 gets executed? So now currently p points to the element of the array at address 112, which is the value at 4. Next, what if I write p equal to p minus 1? This is very easy to understand. Now p will point to the value 3. This is shown here. The next point is very important. What if I write p of 1 equal to 5? What is the meaning of this? Here you can notice, instead of using star, I have used the square brackets or index notation. Now you might ask, what is the meaning of 1? Is it referred to, or does it refer to the element 2? Let us see. Currently p is pointing to 108. So according to p, the base address of this array is 108. So when I write p of 1, it means you are as good as writing p equal to p plus 1, then writing the value 5 at that location. So after 108, which is the next memory address available, which is 112. So this value 5 gets returned to the element at the fourth position. So this becomes 5. So this is shown in the animation like this. So by looking into memory diagram, you can easily analyze various seemingly complicated code for pointers. When you are studying pointers for the first time, it is always important to remember few points related to pointers. A pointer variable can be assigned the address of another variable. We have already seen this. A pointer variable can be assigned the values of another pointer variable. We have also seen this when we saw chain of pointers. A pointer variable can be initialized with null or zero value. Again, we have seen this in the previous slides. A pointer variable can be prefixed or postfixed with an increment or decrement operators. In the previous slide, we have already seen this. When we wrote p equal to p plus 1 or p equal to p minus 1, we could also written it as p plus plus or p minus minus. An integer value may be added or subtracted from a pointer variable. Previous slide, we just saw how this was written. I had written p equal to p plus 2, or I also wrote p equal to p minus 1. So this is possible. When two pointers point to the same array, one pointer variable can be subtracted from another. So this is in fact was not shown previously. So when we make a array to be pointed by two separate pointers, say p1 and p2, in such scenario, one pointer variable can be subtracted from another. This is allowed. And even you can use relation operators. When two pointers point to the objects of the same data types, they can be compared using relational operators. Remember, when if this condition is not true, that means two pointers pointing to the objects of the same data type. If this is not true, then you cannot use relational operators to compare such pointers. This is not possible. A pointer variable cannot be multiplied by a constant, so you cannot write p equal to p star 3. You can try to find a reason as to why this is not possible. Two pointer variables cannot be added. It means you cannot add two pointer variables just like that. Say assume that p1 and p2 are two separate pointer variables, and you cannot write p1 plus p2. Try to find the reason for this. In fact, the reason or the answer for this is purely logical. If you have understood the concept of pointers, you can easily make it out the reason for this. The last point we have already discussed in the previous slides. A value cannot be assigned to an arbitrary address. Means ampersand x equal to 10 is not possible, because we already noted that address of operator cannot be used in an LHS of an expression. Having seen how pointers and arrays are related, we can easily try to find the relationship between pointers and strings. So we can study easily how pointers and strings are related. Actually, pointers and strings are related the same way as pointers with arrays. Why so? Because strings are nothing but one-dimensional character arrays. Since we can associate any array with pointers, same way even character arrays can also be easily associated with pointers. Let us take this example. I have a string called hello, and I have a character pointer called star p equal to null. So when I write this statement p equal to str, it's as good as now this p points to the character array called hello. This is as simple as that. You can notice the similarity of this assignment statement with the previous assignment statements that we saw for arrays. So from this point onwards, I can refer to this p and stop using this variable str to manipulate or perform various operations on this string. Let's now try to compare the implementation of string built-in functions using arrays versus pointers. So in the previous video sessions on strings, what we saw was we tried to implement some of the built-in functions like string length, string compare, string concatenate by using arrays. Now, having seen arrays and pointers are related, we can easily re-implement those programs using purely pointers. So we'll try to compare the implementations of such programs with arrays and pointers, and at the end we'll try to conclude which one will be more easier to use compared to arrays and pointers. Let us have a look into it. We'll first see the implementation of strlen. In the left hand side, I will show the code for implementation of strlen using array. This code was demonstrated in the previous video session on strings in C. You can please have a look into it. You can see purely I have used arrays to achieve this. So till the end of the array is reached, I increment I as well as length. So at the end of this while loop, whatever is the value that is available in length, that will be the length of the string hello stmct. It also includes space. Now the same code can be easily re-implemented by using pointers. You can clearly see the difference here. Here I have the same string, but here I have one more variable called pointer variable which points to the string. So remember, pointers belong to the same data type. So if you want to make a pointer point to a string array, then that pointer must be of type char, because string is a character data type. After this I write s equal to str. So from this point onwards you need not use str at all in your program. You can directly use s to directly manipulate or perform any operations on strings. Let us see how this is done. I write int length equal to 0 while star s not equal to backslash 0. See the difference between this while loop and this while loop. Here I am totally using index notation. Now here I am writing star s. What's the meaning of star s? The value at that address. I am checking whether each element of this string starting from h till t, after t you have backslash 0, whether this is backslash 0 or not. So initially when I write s equal to str, this s would be pointing to h. So h star s is h not equal to backslash 0, which is true. So I increment length, so length becomes 1. So when I write s equal to s plus 1, I know that now this pointer s points to e. In the next iteration it points to l. In the next iteration it points to l again, followed by o, followed by space, followed by s, d, m, c, e, t. So when all this thing comparison is done, length would have been incremented appropriately, and after that it has backslash 0. So when this becomes true, length would be the length of the string without the backslash 0. So after the while loop I can go ahead with printing the length. So this is very easy. And also notice, in this while loop I have not used str at all. I can manage all the show just by using s, but see to it that this statement is written prior to making use of s. And also point to be noted here is s plus plus will increment and point to the next element in that array. See the implementation of strcpy using pointers. This left hand side code shows the implementation of strcpy using array notation. The right hand side diagram or code shows the implementation of strcpy using string notation. So now I am taking two pointers s1 and s2, str1 and str2. So what is the logic for string copy? Copy the ith element of s1 into s2. So from this point onwards I need not use string notation at all or array notation at all. So I will navigate till the array s1 reaches backslash 0, and till that I'll copy each element of s1 into s2. So just by writing star s2 equal to s1, you are as good as copying the individual elements of string 1, which is stm, into str2 one at a time. So in each iteration I'll increment both s1 and s2. So you can see here, this is how I achieved using array notation by using I++. Now I am using increment notation. And after that, since I have modified the string str2, it is my responsibility to add backslash 0. This is how I am achieving it, by writing star s2 equal to backslash 0. Next we'll quickly see the implementation of strcat, which is string concatenation. The left hand side code is the concatenation for string using array notation. The same thing can be implemented using pointer notation also. So again, from this point onwards you need not use string at all or str1 or str2 at all. So in the first while loop, what I am doing is I am navigating the string s1 till it reaches backslash 0. I am navigating s1 or string 1 till it reaches backslash 0. In the second loop, I am copying the elements of s2 till s2 reaches 0 and incrementing s1. So star s1 equal to star s2 means the element at s2, each element as s2 is copied to each element as s1, and I increment both s1 and s2. And since I have now modified s1, it is my responsibility to change the s1. So s1 means str1. So you can see here also in array notation also I used \0. Here also I used \0. Only difference here is, here it's a index notation, here it's a pointer notation. So star s1 points to the value. So hope you understood the differences between index notation and array notation. Having seen all these three operations using strings, now we'll have a quick look into the programs for each one of them. I am now in Fedora operating system. I'll quickly take you to all the programs on string implementation using pointers. First I will show the program on string length using pointer. This was the same code that was shown in the slide, so I'm not going to explain it. I'm simply going to run it. So the string here we are trying to find the length is strcat, so it should print 6 as the output. I'm going to compile it now, run it. So you can see it prints 6. Now what if I try to give a space between stm and cet? Let us see what length it prints. Again I'm going to compile it, run it. This time you can see it prints 7. So the program implementation is correct. Next I'll try to show the program on string copy. Here I am trying to copy the string called strcat into the string str2. This code is already shown in the slide, so I'm simply going to compile it and run it. You can see here now string2 gets stored with strcat. So I'll now try to modify it from strcat to some other word. This time I'll choose hello world. Let us see if I compile it and run it. You can see now string2 is copied with hello world. Same way I can also try to implement string concatenation. Here I have two strings. I will make the string to be read from the keyboard. I'll compile this, run it. I'll now enter hello, and second string I'll enter it as world. You can see it got concatenated. You can also try it one more input, stm cet. You can see now string 1 got concatenated with the string 2. This is the implementation of string built-in functions using pointers. With this, we have come to the end of the session on pointers. I hope you have enjoyed this session. Remember, pointers are one of the most important aspect of programming in C. Because of pointers, C is very powerful. As you become aware or practice more programs on pointers, you will become comfortable with pointers. With this, we will end the session. In the next session, I'll be talking about the concept of functions, how functions can be used to implement modular programming approach. Thank you. Have a nice day.